Let's start with the Marine Geology and Geophysics group and the brave soul who's going to come forward. Brian? Yeah, do you have something you want to show? If you have something that you want to show, memory stick is probably, can you put it on a memory stick? Oh, so you couldn't? Yeah, maybe you can just read it, yeah. Mm-hmm. And then maybe you can send that to Drew later. Send the file to Drew later. So, do you want to come down here? Well, we need you to we need you to come up to the microphone here. Oh, okay. I see. Yeah. No, it's better for you to come up here, and so if you want to read it off, we'll close this down. Okay.
Okay. So those of you who were upstairs with us, just raise your hand. These were a couple people over here, a couple people over here. We were mostly some federal, some academic, and some industry. So I'm Brian Andrews, USGS, and Nadine
Golden, USGS.
And she was our recorder, and I was sort of the facilitator. So somewhere between the two of us, we'll get this.
So it took us a while to get specific on the P's, but what we came down with were 6 of them. We just got 6. So surface analysis for number 1, display of QA/QC for number 2, common platform for display of complex data results.
And also, just to mention that some of these will probably overlap, and we are going first. So some of you may have these as well. You talking there? But we'll say them anyway, even though they may be mentioned later. So the common platform for display of complex data results might be involved with with one of the other groups, the oceanographic group.
So number 4, model builder and geoprocessing results equal good. We just like that. Web services for sharing data both internally and externally. Yeah,
that was 6. And then number 5 was the whole FMGIS FleeterMouse ARC workspace. That's been a huge time saver for us and a lot of our workflows. So that in itself was a huge thing. And we did spend about half the time on what is good. We started really general, and then we tried to refine a little bit. So I think we had a good group, a good mix of people, and hopefully these will be useful. And then we went back to after that we went to the next one. And is this it here?
Yeah. So we have 5 for the minuses, but then before we did that, there were just a few minuses that we just kind of wanted to assume as givens and not take up any of our 5. So do you want to?
So these are the assumed that have been mentioned here all the time. So that's improved vertical coordinate systems, some volumetric measurements and vertical exaggeration, more of the interactive 3D visualization that some of the other unnamed software packages do a really good job at. Also interactive profiling. And then the last one that is a big topic here. It's the unstructured grids, the NetCDF and the non-rectilinear ones. So those were the 3 that were assumed that we didn't even add.
Okay, so for the 5, software version backward compatibility and comparison issues.
And I'll just add that is a lot of us in the government that publish spatial data were sometimes hindered by some of the tools and versions of map documents or spatial data format, shapefiles, geodatabases. We have to publish for the masses, so a lot of times we can't use the most current or most advanced version. We have to assume that people might have ARC, 3 or something like that.
And number 2, dealing with uncertainty, a lot of people have talked about. Number 3, improved vector to raster conversion. Number 4, adopting new formats, and there were some examples.
Yeah, adopting at 10.1, adopting the native read native read to the bag file was a huge improvement for a lot of us in the MG&G community. And we thought, while you're on a roll, maybe we could get you to maybe investigate a couple other formats that might be able to be read. And we said maybe GSF. After all, it is G for general. So
and then
bags were good. Maybe keep going.
And then number 5 was semantic crosswalks.
And we didn't have any eyes.
We had 2 eyes, but they got kind of incorporated into other stuff.
But that was our general P's and M's.
I'm sorry, Brian. Oh, you better not need the list.
Sorry. The raster vector conversion issue, just briefly, is that a bug, a particular data set issue, a performance issue?
Chris, do you want to talk about
What was the problem there?
Who's faster?
Okay, thank you.
Since you asked.
A number of people, not just in my unit, but people we've talked to generally, have noticed that the conversion of a polygon to a raster is really not done properly in existing versions. And it's, I wouldn't particularly mention it, but it's really important in coastal GIS work because a lot of the land data is polygon data and a lot of the ocean data is sparse point data.
So the example you used in our group, though, can you say that? That was helpful.
The example used in our group?
Yeah. You
yes. So down in Louisiana, for instance, we're trying to join the USDA soils to the strand line and then the offshore soils, trying to make a seamless coverage. So we've got a transfer between the different data types. And it doesn't work properly in the GIS.
Did that answer your question?
Yes, I'll send you one.
So you guys mentioned uncertainty is one of the M's, one of the minuses. And I was wondering, one of the great things about the bathymetric attributed grid format, the BAGs, which I think is one of the reasons why Esri has gone with that in terms of our ArcGIS for maritime, is because of the uncertainty surface that's calculated as part of the data structure. So, but I'm getting the sense that BAGs are not as commonly used in the scientific community. So I just was wondering about your impressions in terms of BAGs in general and whether you foresee BAGs as a way to help with the uncertainty minus that you talked about.
I'm going to say real quick that it did come up in our group that the BAGs and we're dealing with that well. There was someone in the group who was using that and was happy with that. But then for everyone else, it was still a problem, and everyone else was not. Or no, some people were, but...
It was the BAGs and the uncertainty that are coupled with the BAGs, good. It was all the other data sets that aren't hydro data sets, how to deal with uncertainty. A lot of it's like geologic interpretations. How do we deal? And it is a sort of a general topic, but also it might be an opportunity for you guys to develop some sort of a standard, either dealing with geologic interpretation or some sort of digitized. I mean, I know there's various ways to deal with it, but it's coming up time and time again. People get a taste for it in the BAGs and bathymetry, and they said, wouldn't it be great if we had, some idea of the uncertainty in all our geologic interpretations or any other interpretations that are actually used for either management purposes or hazard assessment, things like that. So that's what we meant by that.
And then, Don, in general, the rest of your question was just if you foresaw BAGs as being more commonly used. And for my team anyway in Santa Cruz USGS, we're really just exporting those from Keras and not using them until now with this tool in any other way.
And I would say from our group, Woods Hole, the BAG read has been huge. It saved us a lot of time and mostly space. So you have to convert to 3 different formats from going to Keras or Fledermaus. You can go right to. And then you can do anything you want with it. Contour it, hill shade it. So that's that. Anything else? That's it. All right. Thank you.